So it's thinking, okay, I got number line. This is 1, this is 2, and this is 3, and this is 4. And they all said -1, -2, -3, and those are kind of simple enough. But by doing that, then you can describe the movement of the flag. Say, okay, start at 1, 1, and then you move down to, just keep going this way to here. And you actually, from there, you move up to 4 form of chord. So we can trace a movement. And now you have 2 chord. You can actually describe something in a 2D space by the coordinate. And that's 4, 4. Good?
Mm-hmm. Yeah, okay, I've worked with stuff like this with maps and things.
Yep, everything come out. We got streets, a street map. You got basically in streets, normally it's have a center and then just go north and east and west. And downtown Indianapolis, we have this circle in there, right?
Mm-hmm.
Then we got street going either north of that or south of that, east of that or west of that. We actually, if you go to downtown Indianapolis, many other cities, you'll see a north street, a south street, and you'll see a east street and a west street. So have you noticed that? Yeah. And normally things you go through it is called meridian. Meridian street. That means it's right in the middle. Yes?
So Main and that's some like streets we have on our in our town. We have Main and Madison. So
yeah, normally Main is something goes through the city of center, right? So you could call this street Main Street. Right. So that is actually influenced by this coordinate system. And because I have that, then we can describe things like where I am is actually 3387 Parkmore Parkway. So this actually give you a coordinate, right?
Mm-hmm.
First of all, you find the Baltimore Street, and on the street you find the number. So kind of like the street is going, find the street, go this way, then we're just looking at the number, which is one is the X coordinate, one is Y coordinate. Good.
Yep.
Same thing in the city. Once you have that, you got a number and the street, right?
Mm-hmm.
So you find the street, like say South Street. Then you look at the number, whatever number there is, and based on that, you'll find it. You'll find the address. So it came from this idea. You got the XY coordinate, and once you have a coordinate, then you can describe things. You can plan things. You can, if you want to deliver letters, and you know where to go to. Good.
Mm-hmm.
Yeah, and that's actually quite important a milestone for civilization, because now not only you have a place people live, you actually can locate the houses of each one. In the old day, it won't describe like that. In the old day, they will say, okay, you go to that big tree, and to the right of that tree. So you have some kind of landmarks, but you don't really have a coordinate system. So this actually is a big deal. Once you have a coordinate system, then we can graph things. We can explain things, a graph, in terms of the system. Like, for example, if I'm going to tell you a triangle, how do I describe that to you? How do I tell you? Like, without, here I can show you here, but without really for you to see it. Now, how do I describe this triangle?
you could tell us the coordinates on the coordinate system.
Right.
like one
So those
there.
points called the vertex points. As long as I give you those 3 points, you can draw the triangle, right?
Mhm.
So now there's a way for us to communicate without without showing you what I have. Well, that's a big deal because back then you communicate with the letters, right?
Yep.
Nowadays you can go do a Zoom call or whatever, but back then you just have by letters. I mean, how do you explain things to people? Like even just a few blocks down the street, if you just by letters. So now we have a way to tell people. We have to tell people exactly what kind of shape, you know, what it look like and at what orientation by telling them. Like in this case, we know this is 4,4, and this is 1,4, and the bottom here is 1,1. All we need to know, tell someone, just tell them those 3 points. You just tell them, find those 3 points, connect them. You got the triangle that I want to describe to you. Good.
Yeah.
Yep.
Very okay. So from that, we got onto something called linear function, because the reason we call it linear is when you graph a function, it's a line, it's a straight line. Okay, so let's go shopping first. Okay. Now, if we go to a store and we see, let's say buy apples, we have a weight, we have the cost. Now we know that apple is say $2 per pound. Good.
Mhm.
Yeah.
Now, if it's 1 pound, what is the cost?
$2.
2 pound,
$4.
4, 3 pound,
$6.
$6. And now let's look at how we graph this. If we use weight as our x, our y as our cost. So this is our weight, and this is our cost. So 1, 2, 1, 2 is here, 2, 4 is here, and 3, 6 is here. And what do you notice?
Rises.
It's draw the line over what we got.
Oh.
We got a straight line, right? Good.
Mhm.
So now we got 2 sets of data. One set is weight, another set is money. And this table, actually the price, $2 per pound, give us a relationship between those 2 types of data, right? Or 2 sets of data. Good.
Mhm.
Now, if I give you the weight, you can figure out the cost, right?
Yep.
And if I give you the cost, you can also back calculate the weight, right?
Yep.
So that tells us a relation between 2 sets of data. And normally we call one set X, another set is Y. The function tells us how everything get mapped. Good?
Good.
Okay, so that's what a function is. A function we write as Y equal to F stands for function, and X. So in this case, our X is weight, our Y is cost. So knowing the weight, we'll find our Y. And when we graph this, basically is find their like $1 is 2, 1 pound is $2, which give us 1, 2, $2 is 4, and $3 is 6. Then we got those 3 points, and you notice that those 3 points actually fall on the same line. If you connect them, actually we can start from 0, 0, because if you 0 weight, you don't pay money, and this we call the origin, 0, 0. And of course, we have 2 axes, x-axis and y-axis. Good.
Okay.
And with that, we'll be able to not, here, there is a, we're using table to show the relationship, or use table to describe the function, but we can also graph it. We can use a graph to show function. And the third way is that we can use algebra also to show the relationship. If I write this in terms of algebra, and we know that we can write as y equal to 2 times x, right?
Mhm.
So y equal to 2 times x. So when x is 1, we got 2. When x is 2, 2 times 2 is 4. X is 3. 3 times 2 is 6. So this is perfectly describe the relationship here, right?
Yep.
And as a matter of fact, this actually is way more powerful because this shows infinite points, right? Infinite number of points. The table is limited. We can only show mean. We don't want waste time, like just keep going like hundreds and thousands. But with y equal to 2x, this is use algebra to express a relationship, and we actually can cover infinite number of numbers, right?
Okay.
Good.
Yep.
So just kind of a little bit recap. We're talking about function before we can talk about linear function. So what is function? A function basically is a relationship between two sets of data. One set we call x, another set we call y, okay? Now, there could be many different applications. One application we just showed that we got weight versus cost. Now, it could have something like, say, it could be you buy, say, what kind? Maybe a pair of socks. Now, pair of socks you are not by the weight, right?
Mhm.
You are by number of pairs. Number of pairs, and you know the price is mean how much per pair, or sometimes you got $10 for 5 pairs. But no matter what, you still have that relationship. Okay.
Okay.
So that's what we see in our real life, that we see functions everywhere. And also, we can all use functions, especially use the XY coordinate to describe something which is more interesting or more complicated. For example, the temperature during the day. So we can start with, now this is our 0 hour, which is 12 a.m., right? Then you got 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m., 6 a.m., 7 a.m., 9 a.m., 8 and 9, 10, so let's keep going. So this is our time of the day, and this is our temperature. I say we use Fahrenheit. Good.
Okay.
So we could say, okay, started at the 0 hour, we actually got about 30 degrees. And AM go up a little bit, 2 a.m. maybe not that much, 3 and 4, and then we get warmed up, and sun comes up. Then we got, okay.
Mhm.
And so normally we can just connect them, and that line actually is not really, it's not a straight line. And especially afterwards, eventually this thing will go down, right?
Yep.
So this is called a nonlinear function. Yeah. So we really just have two kinds of functions. One are, I mean, big distinction. One is the linear functions, one is the nonlinear functions. And we see both of them in our life. When you go buy something, normally it's a linear function. Or you want to estimate how long it takes for you to drive, given how many gallons of gasoline, and you can actually calculate how many miles you can drive with that. Those are the linear functions. Good.
Okay.
Okay. Any kind of function you can think of, just like in your experience, what kind of functions have you noticed?
What do you mean?
Something like this. You always have two sets of data. Like this is time, and versus temperature versus time. And
Right.
so we can get a function out of it. Can you think of something like you experienced that you can describe that as a function, or you can use function to describe it?
Okay, well, typically when I work with functions, it's typically on a map. So like, okay, if it says to like mark down or go to, coordinate X 15, Y 12, or something like that, I will draw it on there, and that will be my destination, or that would be the coordinates that it showed me.
Right.
That's what you're asking?
Well, that's one of applications of function. I'll give you an example is, how about our height versus how old we are? Okay, so born, that's a 1 year old, 2 year old, and 3 year old, right?
Mhm.
So we can kind of like grow like that. And at a certain point, we'll see a big growth. Somewhere when you get in the kind of preteen, teenage years, and just go like that, right?
Yep.
And then it slows down when you get about 20 something, and they pretty much stay put, then just drop a little bit as you're getting older. Good.
Mhm.
That's one example of function, because you get still two sets of data. Here is how old you are, and here is your height. Good.
Okay.
So functions is always telling you the relationship between two sets of data. And that's what we are interested. Sometimes when we make predictions, we have one data, then from that data, we're going to make prediction. Like say, if you go to a movie, right? You know that ticket, we make that simple. We're just talking about grown-ups ticket. So if you know one ticket is, say, $10, make that easy. And now you can make a prediction, right? You can say, okay, I need 5 tickets. Each ticket is corresponding to 10, so therefore 5 tickets, I need to get 50. Good?
Yep.
So that's also two sets of data. One is number of ticket, one is number of the cost. So that shows you a function. We see that in real life a lot. So anything else can you think of? Jade, can you think of a example?
Let's say I've got an example. Let's say you're like, I'm on my bike,
Mm-hmm.
and I'm on my bike, and I want to see how fast I can get up to like 40 miles per hour.
Right.
So I like pedal, and I can plug it into a graph at like different times.
Right.
See like what my acceleration looks like on like a graph.
Right. Yeah. So we can actually got, in this case, you can get 2 functions, right? Well, it could have 3 functions. One function is acceleration. Acceleration. When you do have acceleration, either you are on the downhill or you have to pedal, right?
Yeah.
Okay. Let's say you start here, you end up there, big time T. So your acceleration could be going up a little bit, and then you're going to drop down to 0. And it could go up a little bit, and then it drop down a little bit, or keep at a certain point, right?
Yeah.
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 And it also kind of speed.
Speed.
Yeah, right. Speed when acceleration when there is positive acceleration, speed goes up. Good.
Uh-huh.
So in this case, the speed will kind of always go up because you keep accelerating. Good.
Yeah.
And then you have the distance. Of course, we could be something like that. So therefore, you actually get three functions here. Good.
Yeah.
Yep. So we see that we use that. Or another function is if I want to track. Some people have the the special watch, like they can track the calories you burn, right?
I don't have one of those.
You don't have those?
No, I actually don't have a watch. I
Okay.
think I've
I mean,
one of those like 4 times.
uh,
I had a couple friends that have them, but
yeah. I got one recently. I just kind of track my heartbeat and the calorie I burn. So that way you can also track it in a day, like when you grow up, like my heartbeat when I was kind of not doing nothing is around 60 pulses per minute. I like to drop it down a little bit. But once I do something, especially if I'm running, I'm guessing to go like this, right? I could get up to like 110.
Wow.
That's you really excited. And of course you cannot keep at that heart rate. If you do that, something bad will happen. You can only do that very short period of time. And then normally it will drop down, right? And so now you're going to have two sets of data. One is time, one is heartbeat. And we can just graph it. But the reason we do that is trying to find the pattern, okay? Trying to find the pattern or find something from that data. We got some information out of it. One thing we could, for example, if we keep the data year after year, so this is like say 2000 and 2001, then 2002 and 2003, right?
Yeah.
So the global average, let's say put some there, just kind of just some fake data, but they just use that show point. Now, if you see something like this, would you have concern?
Well, that would
Depends what it is. It depends on what you're recording.
because it could be the rise in natural centimeters, or it could be the rise in population. Could be anything.
Well, now it definitely is something we need to look into, right?
Mhm.
First of all, what is the trend? I mean, right now we see a trend going up. I mean, that's why people say, okay, there is a global warming, which I don't believe it because I'll tell you why. I mean, data is data. Data is real. It's just like how you interpret that. So if you see that something goes up, now we do have a concern, right? Our concern is if this keep going like that, then we could have a big problem, right? I mean, the sea level will rise and maybe New Orleans will go under, things like that. We do have worry about it. But first of all, is this trend keep going? Or actually we see something like that? I mean, this is kind of in a short scale. Like if you move things up, we actually not only looking at 2000, we're looking way back about say 1900. And
1900, that's a long time ago.
right. Well, we might have data, but if you see something like, for example, okay, you see something like this, do you have to worry about too much?
No.
Well, yeah. Then again, that would depend on what it is.
Well, the thing is, if this is the case, we know that it has been warmer back then, right?
Mhm. Yep.
So now the warming up is probably due to the environment, which is normally could be cyclical, because this one does show there is a cycles there, right?
Mhm.
Now, if that is the case, we could come to a certain point, the temperature goes down, right?
Yep.
Yeah.
So that means it's really not a big worry, right?
Yeah.
So right now we just look at this bit, people are arguing about it, but you have to look beyond me, way back, look at bigger picture. Now, if something like this, we know it's not caused by, it's not really man-made in a way, okay? Whatever we did now, it doesn't really, there is it could be a factor, but it's not a major factor. It could be just global is doing cycling, because which is true, because whatever the temperature we have now, we had that before, like hundred thousands years before. So that's one thing. Another thing is, if it's caused by the natural cycling, then our policy would be different, right?
Yeah.
Good.
Yes.
Right.
Yeah.
So I'm just using this to show the importance of functions, using functions to make a prediction, and also using functions. And also when you're using functions, you've got to be careful. Now, I'll give you another example. If we just look at the check on a person, a baby. Now, baby growth is going something like that, right? Good.
Oh,
What did you say? What was rising?
The growth of baby, the height of the baby.
Oh.
0, 1, and 2, and 3, right?
oh yeah.
Now, can you make a prediction go that way?
Yes.
Well, you could, but based on your experience, is that good estimation or not?
That's a
You know it's about. You know it's gonna drop sometime soon.
Right.
They keep on going, because eventually they'd like reach the sky, which would be strange.
Right. So eventually we know the height has to slow down the growth and even to a certain height, right?
Yeah.
So this just, I use example to show you that people make prediction based on data, but they gotta be careful. If you only have not enough data and you based on this data to make a prediction, you will keep go forever, then you're going to be wrong, right?
Yeah. Yeah.
Right. So that's sometimes in real life, especially when we look at policies, we have to know that. We have to look deeper into it. And that's where like global warming, which I don't really believe, because they only look at not enough data, but they make a prediction, which is 10 and 20 years from now. Now, right now, we couldn't even make a prediction like, let's say, several weeks from now, right? We could not tell the temperature. So we just like, we really don't have that enough data to really to make a good prediction. But that's why we looking at functions. Once we have a function, then we make a prediction. Sometimes things can be easily predicted. Like the law of physics, and something. Also, we have something called cyclical functions. They call sine function. So they go like this, keep going like that, and that actually we can make a prediction. Once we know the cycle, everything just keep repeating like that, right?
Yep.
Yeah. So anyway, just kind of cap this. We kind of look into functions. A function basically is the relationship between two sets of data. Most time we use that is we look at the, say, temperature versus time, growth versus time, or cost versus weight. And then we can use this to help us make predictions. But we gotta be careful, because if we don't, not careful with our prediction, and then we could make the wrong prediction. If I model, in that case, if we use the wrong kind of model, then we'll make predictions. That's actually what science is. Science is always using a model. But if the model is right, we make very good prediction. But if the model is wrong, we make a bad prediction. So when we do science, we cannot really see something with certainty. We can only see what's the likelihood. Is that highly likely or is not likely? But we're always using functions. Then first we got data. From data, we build our function, and from the function, which is basically is building a model. And from the model, then we can make some predictions so that we can do something either to prevent some bad thing happen, or to make something good, do something to make the good things happen. Good?
Yep.
Yeah.
All right. So I'll see you next week.
I think
Okay.
I'm on break next week, so unfortunately I don't think I'll be here.
Okay, that's fine. How about you, Morgan? Maybe today's our last day for this year. We'll pick up next year.
Okay. Well, I know I'll be able to make it next week, plus if something happens.
Okay. Well, let's see. Let's just make today the last day of this year. Okay. So
All right.
we'll pick up in January. Good.
All right.
Okay.
So that way, Jay, so you two will be on at the same at the same pace. Okay.
Okay.
Good. See you. Well,
Right.
Merry Christmas and Happy New Year.
Yep.
You
Merry
too.
Christmas.
Bye.
Bye. Thank you so much.
You're welcome.